Hey, this is Math Minutes Pro. Today, we're going to talk about how to solve problems involving applications of proportions. Okay? So we're going to solve three problems. One of the problems is going to involve a word problem here. So as you can see, I'm going to spend a little time in this video. And you're familiar with proportions. I've created some videos that involve using the cross product. So this is going to demonstrate how you use the strategy of the cross product to solve a proportion. But the main focus is where you use a proportion to solve a problem that requires you to apply the concept of a proportion as a strategy. Okay? It'll make more sense once we get started. Let's go ahead and start. I need to draw a picture, and we're going to be dealing with the concept of similarity. Now, similarity means that two polygons or two shapes, they're the same shape but different size, okay? And so we're going to show you how the concept of similarity is related to proportions, all right? Let's go ahead and get two triangles that are similar sketched up here. So I'll take first triangle and I don't know, guess I'll draw it like that. And let's see, so we have C and this is B and we have A here. Now I'm going to label the side lengths that they give us. Use something different here, different color. So I think this one is 9 centimeters. And this side here, CB, that one is 5 centimeters. Okay. Now let's get our larger triangle sketched here. And we'll make it a little bit bigger. That way it looks bigger, okay? Not drawn to scale, okay, but it's a sketch. And let's see here. We have, this is E, F, and D. Right here, those three vertices, a vertex, it's an angle, the point where two lines meet, that forms an angle. So this is a vertex D. Building a little vocabulary here. And we have for segment DE, there's a little geometry here too, even though it's under the category of algebra. This side length is 27 centimeters. And this side length is X centimeters, okay? Now, they give us some very important information I'm going to write down, and I'll explain it. They tell us that triangle ABC is similar. That is the symbol for similar to triangle DEF, to triangle DEF. All right, this is our given information. That's why I put a line right there. All right, so we have triangle ABC, similar to triangle DEF. All right. Let's see. Now, what we need to do is study this picture and set up a proportion. That is, if you can do that, you're halfway there. And we got to set it up correctly. Now I'm going to give you a little geometry here to know how, because you have to understand how to relate the different sides of the triangles in order to write the correct proportion. Okay? So corresponding parts of congruent triangles are congruent. That means that AB, or segment AB, a segment is a line with two endpoints. AB, see that? AB corresponds with DE. See that? Okay. And segment BC, right here, BC corresponds with segment DE. All right. So if that's true, let's see if we can, and then of course, segment AC corresponds with segment DF. Then corresponds means they're in the same position. Just like you have in companies, two CEOs of, one CEO of one company is in the same position of a CEO of another company. They're in corresponding positions. But the CEO is not in the same, of one company is not in the same position of someone who is a program manager. All right? They're not corresponding positions. They're not same positions. So that's the application of that. All right, let's go ahead and set this proportion up. Well, let's look at what they're giving us. All right? We have, let's take BC. We know that BC, they give us the length of BC. And BC corresponds with EF. So I'm just going to make a little loop. BC corresponds with EF. So then segment BC is 5. And segment on this side of this triangle, smaller than the larger, EF, the length of that is X. So I set up that ratio that way because they're in corresponding positions. So I'll start with what's given. BC here corresponds with, they're in the same position as EF, and EF is X. So I wrote 5 over X equals. Now all I have to do, remember a proportion is where you have two fractions, right, that are equal to each other, okay? All I have to do is write another fraction and use the numbers that are given, okay? So let's start with the same triangle, the smaller one. Notice we're going small to large, 5 over X. So now I have segment AC, that's right here. I'm going to put that loop. And segment AC is 9 over. Now, what does AC correspond with in the larger triangle? DF. So I'm going to draw that little loop from D to F. And what's the length of DF? 27. There it is. It took all that time to write that proportion. Okay, this is very analytical. Don't rush. Watch this video multiple times so you can follow the thought process. But now that we used what we know about corresponding parts when you have two similar triangles, we use that to write the proportion. Now the rest is what you already know how to do, okay? You already know how to solve a proportion. If you've watched one of my other videos, we're going to use the cross product, okay? So here we go, 9 times X. 9 times X equals 5 times 27. Okay, that's the cross product. And I'm going to write this down again, bring this down again. But let's go ahead and do the math. 5 times 27, that's 135. All right. And then I'm going to write this step again. 9 times X equals 135. And now, what property of equality do I use to get rid of the 9, the coefficient? It says 9 times X. What's the opposite of multiplying X by 9? Divide X by 9. So we divide this by 9. That crosses out. 9 divided by 9 is 1. Whatever you do to one side of the equation, you have to do to the other. Divide that by 9. So 130, and then X remains. So then X equals 135 divided by 9, and that gives us 15. Circle our final answer. What that means is the length of this triangle, segment EF, is 15, because that's where X is. But 15 what? Centimeters, right. Don't forget your unit of measurement. Okay? X equals 15 centimeters. That was a long problem. but we got through it. Let's do another problem, and this one involves the use of drawing a picture again. And in this case, we're going to be dealing with a 1, 2, 3, 4, 5-sided figure, which is called a what? Pentagon. So let's go ahead and get that sketched. We have two pentagons that are said to be similar. Okay. All right. Okay, now let's go ahead and label the parts. So this is said to be F, and this is G. We have H. We have J here, and then K. Now, they give us side lengths, and I'm just going to draw a picture. They tell us here that JH is 2 centimeters. And they tell us that KJ is 5 centimeters in length. Segment KJ. All right. Now let's sketch the larger pentagon. And it's going to be upside down. So they do that just to have you think a little more critically. All right. And then we'll come down to a point, a 5-sided figure. Now, in this case, using different colors here. So this vertex is P, Q here, R. This vertex is M, and this vertex here is N. All right. Now they give us side lengths. So let's get those side lengths written in. They tell us that the segment PQ is X centimeters. PQ is X centimeters. All right. And they tell us segment QR is 8 centimeters. So I'm running out of space, I'll just draw a line. And the QR is 8 centimeters. Okay. And we need to label the parts over here as well. So let's get that labeled. Let's see why I'm using a different color. No, yeah, we got it, I'm sorry. Okay, so we have our side lengths given here. Here we have 5 centimeters and 2 centimeters, X centimeters and 8 centimeters. Now, just like we did here, they give us a statement. All right, we call it a similarity statement. This is a similarity statement. We need a similarity statement for this pentagon. So they tell us that, and they don't use, how we use a symbol of a triangle, they didn't do it for the pentagon. They tell us F, G, H, J, K. So F, G, H, J, and K. And the order does matter, so don't change the order of those letters, is similar to M, N, P, Q, R. So that's M, N, P, Q, R. That's the similarity statement for what? The two similar pentagons. Now let's study it like we did before. And we're going to pay attention to what's in what corresponding segments are connected here. So let's look at what's given. Let's start with KJ, or JK rather. So JK corresponds with what over here? Right, QR. So let's write the length of KJ, which is 5 over And what is QR? 5 over 8 is segment QR. 5 over 8. That's the length. See how we did that? You're like, well, where do you know when to start? You just start with, you pick a side where they give you the length of that side. All right? You know, when you set up a proportion, you're going to have 3 numbers in your proportion and then an x value. We got 2 numbers so far. Okay? Now, let's remember we're going from small to large and small to large. So now let's go with JH, right? Or HJ in this case. So HJ corresponds with what over here? Okay? HJ corresponds with segment PQ. So what's the length of HJ? 2. What's the length of PQ? There it is, X. The proportion is set up correctly. You can't just pick any numbers. They have to be, the sides have to be in corresponding positions. Okay? And we use this similarity statement to help us decide what segment corresponds to what. So there we have it. 5 over 8 equals 2 over X. Now you know how to do the proportion or use the cross product as a strategy. 5 times X equals 2 times 8. So let's go ahead and set that up. 5 times X equals 2 times 8. There we go. And let's go ahead and simplify. We can't do anything to 5 times X, so we bring it down. Bring down the equal sign. 2 times 8 is 16. Just like we had to use the division property of equality over here. Same thing here in order to get rid of the 5. So I'm going to write this again. The opposite of multiplying x by 5 is to divide x by 5. So we can get rid of this coefficient. 5 divided by 5 is 1. Right, and whatever you do to one side of the equation, you have to do to the other. We're going to divide 16 by 5. And then what do we have left? X equals 16 over 5. All right, we can't reduce that fraction. We got an even and an odd number here. And what's the unit of measurement? Centimeters. This is our final answer. Again, we are applying the concept of proportions to solve a problem. Now we're going to get into a real world problem that could actually happen, okay? Still dealing with the application of proportions. So let's say we have a person who is standing next to, I don't know, some kind of pole, telephone pole, light pole, utility pole, I don't know. That person has a certain height, and when that person, it's a sunny day, so when that person is standing next to the pole, the person casts a shadow, and that shadow has a certain length. So the person has a certain height, and the person also shadow has a certain length. But that pole also has a height, and the pole also has a shadow. And so we need to find out how tall is the pole, or what is the height of the pole if we know certain information. So I'm going to sketch a picture for you to illustrate this, all right? Let's see. So let's say this is our person, smile, all right, stick person. And that person has a height, right? And that height, the height of that person is 5.5 feet. So I'm going to draw a line and say the height is 5.5 feet. But remember, we also said that person has a shadow, okay? Well, the length of that person's shadow, okay, I'll just have it go in that direction. This is the shadow. That person's shadow is 4 feet. So the person's height is 5.5 feet, and that shadow that's casted is 4 feet. Now let's sketch a picture of the pole. So let's just say this is the pole, okay? And the pole has a certain height, and that height is X, okay? And the pole casts a shadow. This is the shadow. And the length of the pole's shadow, okay, is going to be 20 feet long. Yep, starting to look like a proportion. Yeah, I think you can see it. Think about it. The height of the person corresponds to the height of the pole. The length of the person's shadow corresponds to the shadow, the length of the pole's shadow, okay? All right, and I'm just gonna put, this is a pole here, all right? So in the word problem, let's say it asks you to write a proportion and then solve for X. So that's what we're going to do. All right, so this is the problem, and well, let me put that, let me write that down. So we need to write a proportion and then solve for X. Now, all right, make that explicit. Well, here we go. Let's think through this thing. We can do this, all right? Well, you might even just set it up. You know your proportion is going to look like this, right? All right, so here, let's go from, I'm going to go from pole to pole, all right? Starting with the person, from person to pole, so, or actually the height of the person to the height of the pole. Let's do that. So we know the height of the person is 5.5 feet. So I'm going to write 5.5. And that corresponds to the height of the pole, and the length is X. We don't know what that is yet. Now let's go back to the length of the shadow of the person, which is 4 feet. And the length of the shadow of the pole is 20 feet. There it is. That's the proportion. We went from height, we went from person to pole, and we went from height to height, right? And then from shadow to shadow. Okay? So let's double check that. The height of the person is 5.5 feet. The height of the pole is X. The length of the shadow of the person is 4 feet. It says it right there. And the length of the shadow of the pole is 20 feet. Okay, so now we're ready for the cross product. So let's use the cross product. And let's do the math. 5.5 times 20 equals 4 times X. Very good. All right. So then 5.5 times 20 is 110 equals 4 times X. Okay. I'm going to write this again so I can illustrate the division property of equality. To get rid of the coefficient 4, I need to divide the side by 4. Whatever you do to one side, you do to the other. 4 divided by 4 is 1. So what do we get? We're left with x equals, now what is 110 divided by 4? 27.5. 27.5. What's our unit of measurement? Feet in this case. Okay, and there we have it. All right, we had a word problem. We sketched a picture, right? We use our understanding of corresponding positions to write the proportion. We use cross product, and we found the length of the height of that pole without having to climb up there if you know certain information. Okay? That's wonderful. That's the power of mathematics. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.